Welcome to the lecture 3 of Python and Matrices course. In today's lecture, we will be still focusing on vectors and matrices and specifically cover three main topics. One is linear transformation, the second is matrix multiplication, and the third is determinant. As alluded to you previously, all the topics that I will be discussing today will have definitely the numerical component or the equation that you use to implement all of these operations. But on top of that, most important thing is through the use of these lectures, I also want to give you the geometrical intuitions behind these operations, which will solidify some of the concepts in a different way. So let's get started. So the first topic that we're going to cover in today's lecture is about linear transformation. And in order for us to first of all understand what linear transformation is, first let's take a look at a concept that we can relate to, which we might have used previously, which is the idea of function, right? So typically when we are talking about functions, right, we have a function that is defined, and a function essentially will act as a processing unit where we supply it as one input and we can get an output out of this function itself, right? So function is something that takes in the input and spits out output. And we can take some example with respect to this function that we have. For example, if I pass on 1 to this function value, then the output of this function value is going to be 1 cube plus 1, so that is going to be equal to 2. Now, if you supply input 2 to this function, then the output will be 2 cube plus 1, so 2 cube is 8 plus 1, so the output in that case will be 9. Similarly, if I supply 3 as an input to this function, then 3 cube plus 1, so 27 plus 1, and that will be 28, right? So this is how a function does input to output mapping, and essentially the idea behind transformation in general is also, so it is something which takes an input and spits out output, and we will connect to that in a little bit, but I just wanted to revise this function idea so that you can connect with the piece going forward. Now, this is an example of a function where we have essentially a single input and single output, right? So we have only one input, which is variable x, and there is only one output, which is x cube plus 1, whatever is the output inputted by this, which is, that's why I've written here, we have a single input and single output function. But in many cases, it might be interesting also to create, multiple inputs and multiple outputs, right? And one of the examples could be where essentially you are doing transformation from polar coordinates to Cartesian coordinates, and this is something that you do. So in this case, you might have, 2 inputs and 2 outputs. So if you look into this, set of equations that has been written here, and in order for we to use this equation, this box, what we need to do, we need to provide 2 inputs, which one is r and the second is theta, and then we can get 2 output, which is the corresponding values of coordinates in the Cartesian system, right? So x and y, which will be outputted in the Cartesian. So we basically provide the coordinates in polar system, but this function basically outputs in the a Cartesian coordinate. So here is an example of multiple inputs and multiple output function, and this is an important one. You can take this and you can extend this idea in into cylindrical coordinates in 3D and so on, which is also multiple input and multiple output type of function that we are dealing with. So here you will essentially provide, let's say, a pair of number, okay, and this pair of number could be 1 and 45 degree, and you will get some coordinate x and y out of this function transformation. Okay, so this is an example where you have multiple inputs and multiple outputs in the function, right? And here we are providing two tuple input and we are getting 2 tuple output. So one way to think about the linear transformation, which is the main topic that we want to cover today, is essentially it's also a function